All right, guys, I'm going to show you here how to solve all of the problems for checkpoint A to help you study for checkpoint B. So number one, remember anything to the 0 power, because this is in parentheses, we're good to go. It's the whole number. Anything to the 0 power is just 1. Number two, follow the steps that are written on the board. So before you decide whether this is negative 16 or positive 16, make the exponent positive by moving this to the bottom. So it would be 1 over negative 4 to the positive 2. That changes the exponent to positive. Then, if you don't know that that's negative 16, just put it in your calculator exactly like it looks, no parentheses. That would equal negative 16 on the bottom. So 1 over negative 16 is your best answer. Number three, the only thing that's not simplified about this problem is that t has a negative exponent. So just move t to the bottom. The 7 has its own exponent. It's a positive 1, so leave it alone. 7 and a to the third stay on top. T to the positive 5 is on the bottom. Same kind of deal with number 4. The only thing wrong with this, the only thing that's not simplified, is that g has a negative exponent. So bring that to the top to make it positive 9. It would sit on top with the 11, and the h to the 7 would stay on the bottom. Number 5, anything to the 0 power is 1. Cross off the 13. The 9 has a problem. It's not simplified because it's a negative exponent. So bring that to the bottom. So 1 fills in the top. And it'd be 9 to the positive 2 on bottom, which 9 squared is 81. So remember, last step is to calculate your numbers. 1 over 81 is the best answer. We'll circle that just for the sake of keeping them all the same. All right, number 6, all of these can be combined, so you need to do that to make it simplified. You add the exponents. If you know that you are bad at adding negatives in your head, there is no shame, you guys, in typing that in your calculator. That would be m to the negative 5th. And you cannot leave it like that. You need to move it to the bottom, so 1 over m to the positive 5th is the best answer. Number 7, I kind of covered that up, but you definitely want to put the r's together right there to make it simplified. The 4 is good to go. Can't make that any better, but 8 plus 3 would be r to the 11. Number 8, so this is just a multiplication problem. Put parentheses, you could take those out. You're just multiplying these two things. So the big numbers, the 7 and the 6, actually multiply those. That's 30. And then, here, let's do it right here. And then bring the ends together by adding negative 8 plus 3. Again, if you're bad at adding that in your head, do negative 8 plus 3 in your calculator. It's negative 5, which needs to come to the bottom. So the best answer, leave the 30 on top, 30 over n to the positive 5th. Number 9 is also just a multiplication problem. So all the big numbers, just a 1 there. All the big numbers can be multiplied. So negative 4 times 2 times 5 is negative 40. Be careful here. So there's x's and y's. You add exponents to bring x's together. So that'd be x to the negative 5. Y would be negative 2 plus 5. Then look at what you have and only move what has a negative exponent. The negative 40 has an exponent. It's a 1 and it's positive, so don't move that. Just move the x. So negative 40 and y stay on top. X to the positive 5 moves to the bottom. All right, there's that first chunk of like simplify that group of problems. 10, 11, and 12 are scientific notation. So note that it says make sure you write your answer in scientific notation. I haven't even graded your test yet, but guys, I'm betting that people are like, oh, let me just take that. I can put that in my calculator. Why not? And they're going to write that massive number, which fine, that's not wrong, but that's written in standard notation. I need to write that number in scientific notation. So So there is a little shortcut here. What I do is I just multiply 0.2 times 4, and that's 0.8. And then I just bring down 10 to the 8th. And then I can just write that in scientific notation. Remember, if you just move the decimal, I can make it like 8 or 8.0. If you move the decimal, you adjust the exponent. I went from 0.8 to 8. I made this bigger, so I make this smaller. So that's the answer. That's the same thing as that number that I just had on my calculator. There's a trick here with this guy too. So you can multiply, these are both really small numbers because they have negative exponents. So the trick for multiplying these two scientific notation numbers is multiply those first numbers right there. So that's 28.7. And then to bring the tens together, you just add the exponents. Negative 6 plus negative 2, which would be negative 8. Goal is to write it in scientific notation. This is not because I need to move the decimal. 2.87 times 10 to the, okay, I made this smaller, so I make this bigger, negative 7. And then 12, same deal. If it's a division of scientific notation numbers, you just divide the decimals that are between 1 and 10, so that's 3.2. And then the rule with the tens is subtract the exponents. 13 minus 5 would be 8. And that's good to go. That's between 1 and 10. All right, number 13. Distributing the exponent. Let's start with a big group of simplifying. So when you distribute the exponent, you just multiply. End of the 27. Number 14, same thing, except don't forget that 3 has an exponent. You need to distribute to that guy as well. That does not change the 3. It just changes the exponent. 4 times 1 is 4. 4 times 8 is gross 32. Last step, we take it to our calculator. 3 to the 4th, I can rewrite that as 81, G32. 15, okay, step 1 is to distribute the exponent. I know that there is a 1 there, and that's it. Okay, so distribute the 2 to those guys. Oh, 1 there. Distribute the 3 to those guys. So it's going to be 3 squared, x to the 4th, y to the 6th. 2 to the 3rd, x to the 12th, y to the 9th. Multiply exponents. Then combine things. So x's, add your exponents. There is 4 plus 12, x to the 16. The y's, 6 plus 9, y to the 15. And then here's what I'm going to do with the numbers. So these are just numbers, and all of this is just being multiplied. 3 squared is 9. 2 to the 3rd is 8. So all you're doing is 9 times 8. So that's the best number to write in front of those variables. Number 16, fraction. To bring the m's together, you just subtract the exponents. So 12 minus 7 is m to the 5th. 17 looks like 15, and you're distributing the exponent. I would go in and put 1s on all of those that did not have an exponent originally, and then distribute the 2. So it would be 5 squared, x squared, y to the 4th, x to the 6th, y to the 6th with the second group. And then, guys, this basically is the exact same problem. So 5 squared is 25. That's the only big number. Add the x's, so x to the 8th. Add the y's, y to the 10th. That's kind of lame that those two are so similar. 18, a common mistake will be with the number right here. That is just division. Just like these two numbers were just being multiplied in a fraction, those are just being divided. So it's just 15 divided by 5, which is just 3. And you'd write that on top. Then bring the ends together by subtracting the exponents. So 11 minus 3 is 8. 2 minus 6 is negative 4. You always write them on top after you do that subtraction trick. Then say, oh, okay, I know I can't leave it, so the m has to move to the bottom. to make it positive, that's the best answer. 19 and 20 can be tricky, but same deal. You start by distributing. I put ones in there. I'll do the same thing over here. Otherwise, it's easy to miss something. Okay, that does not change the 3 or the 2 or the x, just the new exponents. So it'd be 3 to the negative 2, 2 to the negative 2, and x to the positive 8. Next step would be, since I can't combine anything, is to move stuff. So I'm going to move the 3 down and the 2 up. So that would look like 2 squared over 3 squared x to the 8th. Then rewrite those numbers. So 2 squared is 4, 3 squared is 9, x to the 8th. Number 20, same thing. You just got to distribute to all of those guys, even what's on the bottom. Don't let that confuse you. It'd be 5 squared, p to the 6th, n to the negative 8, over p squared. Distribute, then combine. I can put those p's together. 6 minus 2 is 4. So p to the 4, n to the negative 8. Then move the n down, and you're also going to write that as 25. P to the 4 over n to the positive 8. A lot of steps. Okay, on these two, if you missed these two, when you see these problems again on checkpoint B, don't start by plugging in for n and m. I would start by simplifying. So do what we just did up here. Make this look nicer, and then plug in for n and m. So I would distribute first and say, okay, that's just n to the 4th, m to the negative 2. And then I'm going to put the m on bottom, so n to the 4th over m squared. Then I plug these numbers in. And when you plug numbers in, guys, you have to use parentheses. So n is negative 2 to the 4th, m is 5 squared. I would just take it to my calculator. So parentheses, negative 2 to the 4th is 16. I know 5 squared is 25. There's no negatives. That's the answer, 16 over 25. Same deal with 22. Simplify first. Okay, do that on checkpoint B. Get rid of the m. That's just 1. Put your n's together. You subtract the exponents, so it's n squared. Now plug in negative 2. Do not screw this up. You have to do parentheses. If you didn't do parentheses, it would tell you negative 4, but this is positive 4. That's your answer. All right, last page. So growth and decay problems, and then the graphing, which was that last lesson we just did. So 23, your dad bought a baseball card years ago that was originally worth 5 cents. It grew in value at a rate of 20% per year. How much would the card be worth after 50 years? Okay, remember the setup is A times B to the X. A is the original amount, 5 cents. B is the rate. That's where we mess things up. Identify first, is this growth or decay? Okay, so the value increases. Okay, it grows. So this is growth. Remember, for growth, you do 1 plus the rate. So you're going to write this as a decimal. Move the decimal 2 places. It's 0.2. So 1.2, that's your B value. X is your time, so if I want to know 50 years, I just plug that in right there. So it would be 0.05 times 1.2 to 50, no plus sign. All right, and then that's going to tell me how much this card is worth. Oh, if this was legit, that'd be awesome. So after 50 years, this card that my dad bought would be worth, and write a number that makes sense money-wise, $455.02. That would be pretty legit. 24 is the same thing. And you guys, I bet if this one was growth, this one is probably decay. And yep, what do you know? It depreciates. So this one is decay. Probably see one of each. You bought a car 5 years ago, and it was worth $24,000 at that time. If the value of the car depreciates 20% every year, how much is it worth today? Okay. Initial amount was $24,000. It depreciates 20%. So same percentage here, that's kind of annoying. But when it is decay, you do 1 minus 0.2. So 0.8 would be my rate. And then to the x, well, I bought it 5 years ago, so what is it worth today? Well, it's been 5 years, so let's plug that in. That's my time. 24,000, 0.8 to the 5. My car would currently be worth $7,864 and 32 cents. All right, last two are the graphing, so here we go. I'm just going to make a table. If you remember the little trick, good for you. Go ahead and use it. If you don't, I would resort to the table. Remember that we always did -2, -1, 0, 1, and 2. So we just plug in one at a time for x. So I'm going to do the fraction button, 1 ABC 3, and then caret one at a time my x values. So that's 27, 9, delete the negative and put 0. And 1/3. Don't let that weird you out. All right, so let's plot these. -2 up 27. I mean, that's going to go way off. -1, 9. I know it's going to be that curve shape. 0, 3, 1, 1, 2, 1/3. I mean, that's like between, it's under 1, just to kind of estimate right there. Then you can get your shape going. Remember that it should not cross the x-axis. You crossed it down there, I probably did -1 on your test. Don't do that on checkpoint B. All right, last one. Plug them in. So 0.5. That probably scared some of you, but that's okay. -1 is 1. 2. 4. And then 8. All right, plot your points. So -2, left 2, up a half. So it's just going to be like right there. -1, 1, 0, 2, 1, 4, and then 2, 8. Again, don't let it touch the x-axis down here. Get your arrows on. And that's it.